So for this problem, we have a cube that sits on the coordinate system origin. It has a magnetic field in the positive z and a velocity in the positive y. So if we look at the equation for the force for the magnetic field, we see that the direction of it is going to be in the positive x direction. Again, this is by the right hand rule. So if we put our hands in the direction of v, which is straight up, and curl to your fingers towards you, your thumb should be pointing to the right, which is the positive x-axis. But since the charge that's moving is negative, because we have an electron, it means that the force in this case is going to be in the negative x direction. So if we look at the cube, then what we're going to see is if all the charges are moving to the left hand side, right, this is where FB is going to be pointing. That if I look at a face-on, then all the electrons are going to go to the left, which means I have an excess charge on the left hand side, and then I'll have an excess positive charge on the right face. This is going to produce an electric field, as we know, so this will mean that the right face is at higher potential and the left face is at a lower potential. So let's look at part B. If we look at the force electric, we know that the electric force is given by the absolute value of the charge times the electric field, and the magnetic force is given by QV B sine theta. These are magnitudes, of course. And because V and B in this case are perpendicular, it implies that the magnetic force is just going to be QVB. So the potential is given by the electric field times the distance, and the electric field itself is given by, if we look at this equation, we have QE equals QVB. If we cancel the Q's, we get that E equals VB, where this V is velocity. So now we can write that the potential is equal to the velocity times the magnetic field times the distance. And we know these values. We're told that the electrons are moving with 4 meters per second and a magnetic field of 0.05 Teslas, and they're moving for a distance of 15 millimeters. So this gives us a voltage of 0.003 volts, or 3 millivolts.